Hi, I'm David Reed with Equilibar, and today I'm going to show you how the Equilibar high-speed vacuum regulator can quickly respond to changes in flow in your vacuum system.
I'll give a quick description of what we were looking at out in the laboratory. Then we'll jump back out into the laboratory and have a look at it all in action. The main thing we're looking at is this high-speed, fast response vacuum regulator. This vacuum regulator is controlling the pressure here. It's connected to a vacuum supply here. It's a pilot-operated valve. It receives its pilot signal from an electronic vacuum regulator. It's a small black box you'll see connected to the pilot port of the large gray PVC high-speed vacuum regulator. We're going to set a fixed command. It's going to control a fixed vacuum pressure here. And what we're going to do is with this on-off valve, we're going to put a flow disturbance into the system. Essentially, we're going to go from no flow to full flow with this on-off valve, and then back again. The flow rate that we'll be setting will be set here with just a ball valve that we're going to set about halfway open. That limits the maximum flow rate into the system. That flow rate, again, will turn it on and then all the way off with this fast actuating ball valve. We're just drawing air from atmosphere, and what we'll see is when this on-off valve turns on, we're going to see the disturbance that has in the system and the ability of the vacuum regulator to make up for that. We'll be watching that on a chart recorder. And the chart recorder is just going to display this vacuum transducer signal. One thing we're going to do in the lab is we're going to toggle a volume in and out of the pilot. So with no volume, the electronic regulator is able to change the pilot signal very quickly. So if you need to change the vacuum set point quickly, we'd go with no volume. And in a case like this where we have an on-off valve where the pressure that we want to control is stable, static, but the flow going in and out of the system alternates, we actually add some capacitance to the pilot, and that allows the vacuum regulator to quickly shift position and make up for that flow disturbance. So let's run back out in the laboratory and see that in action.
Now we're back out in the laboratory. Let's take a look at how that schematic lines up with the actual pieces we have. Starting back here, we have a 40 horsepower vacuum supply pump. That vacuum supply pump is supplying an Equilibar high-speed vacuum regulator. That's this big gray PVC regulator that you see here. Pilot operating that regulator is a QPV electronic vacuum regulator. The vacuum regulator is controlling the vacuum here, and we can see what that vacuum level is with this vacuum transducer. The vacuum transducer is going to display on this chart recorder. We're going to use this to establish the set point for the electronic vacuum regulator that's pilot operating the main vacuum regulator. Change over to here. You'll see that we have our high-speed on-off valve, and I'm going to manually actuate that with an electronic signal. This is in the closed position. This is in the open position. In the open position, we're getting full flow. Full flow is determined by where I set this ball valve. I've got it set at about midpoint right now. And we're just drawing air in from outside, from atmospheric air. Let's go ahead and fire the system up and see what happens. Now we've got the vacuum supply pump running. A little bit of noise in the background. We've got the command set to 40%. And I'm going to show what happens when we increase the command signal to this electronic vacuum pilot regulator. We're going to bring the command up to about 50%. And then we're going to take a look here on the chart recorder. We'll see that that was a pretty quick response. We were able to change the set point vacuum pretty quickly. Now let's take a look and see how quickly it will respond to a change in flow. To do that, we're going to modulate this on-off valve. So we'll modulate it 2 or 3 times here. And now we can come over and take a look at the chart recorder. We'll actually see what happens when we turn that on-off valve on. We get a change in the flow. Now we're going to take a look at the response when I've added this volume chamber. So between the electronic regulator and the diaphragm of the high-speed vacuum valve, we've added this much volume. So we should see a slower ability to change the pressure, but a better improved ability to respond to changes in flow in the system. Let's see if that's true. Let's change the command again from 40% up to 50%. And if we take a look at the chart recorder, we're going to see that it takes a lot more time to change the set point pressure. However, if we slide around to the vacuum, the on-off valve to put flow into the system, when we turn this on, the vacuum regulator ought to have an improved ability to respond to that. Let's see. And now if we come back over to the chart recorder, we'll see that each time I actuated that valve, we only got a small disturbance in the actual vacuum pressure. Let's see that one more time. So full flow, the same flow that we had before, the same flow disturbance, but the amount of vacuum change in the system is dramatically reduced. That's because of the Equilibar's high-speed ability to respond to changes in flow in the system. Equilibar vacuum regulators are available in a variety of sizes, from 1/4 inch through 4-inch pipe size. They're available in a variety of materials, from plastic like this model to stainless steel and also aluminum. They're easy to control electronically, as we demonstrated in today's video, or you can provide a mechanical manual pilot like this one. If you'd like to learn more, visit us online at equilibar.com or give one of us a call.